Hi everyone, how you guys doing? Hope everyone is doing well. And yeah, let's keep going where we left off last time. So last time we talked about vectors, how vectors work. We talked about how vectors internally handle how they handle themselves in memory. We talked about the for loop, what a for loop is, what's count, what's capacity, what's the differences between those two. And we said you can optimize the vector by reserving an initial amount of memory up front rather than data being copied from one memory location to the other. We also talked about binary. Sorry, we didn't talk about binary. We talked about how decimal numbers work, how hexadecimal number works or work, and how the memory layout or how memory works essentially. And all that. We briefly talked about, very briefly, we didn't even talk about it, we mentioned the stack and the heap, which we will talk about later on, right? But yeah, we covered all of that. So what I would like to do today, this is what I want to do today. Today, I want to actually fire a bullet, right? Fire a bunch of bullets from one location to the other, right? And so we have our vector ready. It's all set up. All I want to do now is actually fire the bullets. Okay. So before I start with that, I want to kind of explain to you how we can move an object or a sprite from one location to the other. How can I say if the player is over here and the enemy is over here? How can I move a bullet from this location in this direction? So I move it the first frame here, second frame, third frame here, fourth frame here, fifth, sixth, seven, eight, nine, right? So I'm moving the bullet from here all the way to here. How do we do that? How do we say, hey, move in that direction, or move in this direction, or move in this direction, and so on and so forth? Well, it all relates to vector math, right? So let's take a very simple example. Let's say my player is over here, right? Let's say my player position currently is 100 pixels down, right? So this, if this is 0, 0, right? And this is 1920 by 1080. This dot is 1920 by 1080. This dot is 0, 0. Somewhere in the middle of the screen, you can just do a simple division here. 1920 divided by 2 is 720. Divided by 2, it's 7, or sorry, not 720. 960. So this point here, right, is 960. And 1080 divided by 2 is 540. Right? So this dot here has a position of 960, 540. Alright, so what if I want to move my character to the right? Right? What do I do? Well, this is the x-axis, right? And so I increment on the x-axis by a specific amount, let's say by 10. So every frame I'm increasing its position on the x-axis, and this is the x-axis, I'm increasing that by 10. So the first frame we're at 960, second frame we're at 970, and then we move to 980, 990. Right? I'm just moving in this direction on the right, to the right side. Okay, that's fine. That's all nice and good. And that's pretty easy, right? All right, what if I want, instead of just moving to the right, let's say I want to move to this location, right? Or, yeah, let's move to this location. And so this location is around, I don't know, 1,500 pixels on the x-axis, and maybe 200 pixels on the y-axis, or even like 100 pixels on the y-axis. How can I move in this direction? Well, the really cool thing is there a formula for that. And the formula is target minus current location. So now the question is, where's my current location? Well, this is my current location over here. All right, so 960 and 540. So this is my location. What is the target? Well, my target is over here. I want to go here. This is my target. So that's 1,500 and 100. Right? So this is my target. This is my current location. I would like to subtract the two. Subtract this from this. Subtract these. And then subtract these. Because we want to subtract the x-axis. This is x, and this is x. So subtract these together. And this is y, and this is y. So subtract these together. Okay, so let's do that. What is the tally here? Well, if we get our calculator and say 1,500 minus 960 gives us 540, comma, and then here we do 100 minus 540, we get minus 4040. Right? So this is my direction vector. So look at this direction vector, right? It says the x-axis is positive. So we're basically moving. If we start from this dot, we are going to move from here to here 540 units or pixels. So if my starting location is over here, means I'm moving to the right 540 pixels. And then I need to go up, and notice this is negative. And remember we said that this is minus y and this is positive y. So whenever we're going up, we're going in the negative direction. So now this distance over here, this distance is over here, is minus 440. So now we have two vectors, right? We go first to the right, all the way to the right. Right? We go all the way to the right, and then when we're done, we move up. So this vector now looks something along these lines. This is now my vector. Okay, so this vector has a direction of 540 and minus 440. This vector over here. You can completely ignore these two, right? So this vector over here. Okay. The problem with this vector currently, right? And it makes sense because look at this. I'm going to the right, then I'm going up. All right? If I pick a different location, let's say I pick this location over here, this dot. I would like to go to this dot. And this dot location is around, let's say, 100 pixels down and 50 pixels to 100 pixels right and 50 pixels down. So this position is 150. So if we do the math, again, we subtract, this is my current position, right? So 960, we say that, what's the formula? Formula is target minus current location. So the target is this. So 150. What's my target? This is my target. What's my current position? This is my current position. 960 and 540. If we subtract these two, now 100 minus 960 is 860. or minus 860, right? And then subtract these two together. This is minus 490. So notice this, both of these are negative values. Because when I go to the left, I'm going in the negative direction, right? This is the negative x-axis over here. So this vector now, right? This vector over here has a length of minus 860. And then I have to go up, right? To go up here. And that has a length of, or I need to go up 490 pixels. And so now this entire vector over here this entire vector over here, right, is minus 860 comma minus 490. Because I go to the left, negative direction, and I go up in the negative direction. Right? Okay. The problem with, so now I know this location. Like I understand subtracting this location from this location, I know the direction of my vector. My vector needs to go this way. So the problem here, essentially, is that if this is my location, right? Over here. That means in order for me to reach this point, I need to first go minus 860 pixels to the left, and then minus 490 upwards. Okay? And that gives me that vector. The problem here is that if I say, this is my position, right? So if I say position plus equal to minus 860, comma, minus 490, right? So what does this do? I'm incrementing my position, my current position here. This is my position. I'm incrementing my current position by this vector, which means this guy is going to move in this direction to this location, right? Which is minus 860 and minus 490. The problem with that, this is being done in a single frame. I do this all in a single frame. Sorry, I hit the mic. Right? I shouldn't do this in a single frame. I should do it in smaller steps, like small incremental steps. Very tiny, small steps. Okay? Because right now, the magnitude of my vector is really long. It's really large. Right? That's the magnitude of my vector. And so what I should do here is do something called normalization, or I should normalize my vector. Whenever you normalize a vector, you're essentially saying, I would like this vector to keep pointing in this direction. So my vector is still going to point in this direction. However, the length of my vector, how big it is, right? This entire length is much smaller. It's a unit 1 vector, meaning that the length is equal to 1. This length currently is not equal to 1, and we'll calculate the length over here. But the length of this vector is not 1. So when we normalize a vector, we basically take this vector over here and make it a unit 1, which means that it points in the same direction. However, it's now a unit 1 vector. It's much, much shorter. So imagine this now. Rather than moving all in one single frame, right? Rather than just going from this location, from the first frame, to the second frame, going to this location immediately, which would mean I teleported from here to here. Now I'm moving in a smaller incremental steps. I moved by this amount, and then 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 I moved by this amount. So how many frames did it take us to move? So 1, 2, 3, 4, 5. 5 frames. So I'll give you the illusion of motion. Right? Because I'm now moving incrementally, not just teleporting from one location to the other. And so if you want to go anywhere in the world, you'll really have this formula. Target minus current location. What is your target? Where would you like to go in the world? So get that position. That's a vector 2, right? A vector 2, F. So the target is where I want to go, and my current location is also a vector 2, F. And that's where I currently am. So this will give you a direction vector. My direction vector is equal to the target minus my current location. That's my direction to it. And again, the problem is that it'll give you a big vector, like a big giant vector to go there immediately. I don't want to go there immediately. I want to go in incremental steps. So what I have to do is take this entire direction and normalize it. When I normalize this vector, now it becomes a unit 1, meaning the length, rather than, for example, let's say this length is 10 or 9.5. Instead of this length being 9.5, it now becomes a unit 1, which means every frame you're just moving by this amount, which is super cool, right? That's the entire idea. So what are we going to do is that we're going to spawn a bullet at this location, at the location of the player. And then we need to calculate the direction of this bullet. Where's this bullet going? Once we calculate the direction to the enemy, so the target will be our enemy position. Our current position is the bullet position, and that will give me my direction vector. And like I mentioned, the direction vector is pretty large, the length of it. So rather than having it pretty large, we normalize it to make it a unit 1, which means now my bullet moves slowly every single frame. It goes there rather than teleport there. So that's kind of the entire idea of this whole thing, right? And so we want to start and implement that and work with that, right? But right now, before I jump into that and implement that, I'd like to find out the magnitude of my vector. How long is this vector? So if I look here, this is my vector, right? So if I go here, minus 860, comma, minus 490. Is that correct? 490, yes. So I would like sorry, I had to sneeze. So I would like to calculate this vector. How long is it? We know that it points in this direction roughly, because we know that this is pointing to the left. That's negative, and then I'm going up somewhere, and so that's kind of my direction over here, right? This is my direction. Right, so if I start over here, I'm going in this direction, because I go this many amount to the left and this many amount to up. Okay, how do I calculate the magnitude? Well, that's really simple. It's pretty easy. It's not difficult at all. To calculate the magnitude, you have to figure that out. I don't remember how to calculate the magnitude. It's been a while since I calculated the magnitude on my own. So Google help calculate magnitude of a vector. I think you use Pythagoras theorem. Vector. Yeah, I think you use my Pythagoras theorem to do that. Yeah. You basically, in order for you to calculate the magnitude, you take A, you square it, you take B, you square it, you add them together and you get the square root. Let's do that, right? So let's do that. Minus 860 squared plus minus 490 squared, and we get the square root of that. Let's do that. It's easy. 860. We're gonna forget the minus. We're gonna pretend these are absolute values. So these are all absolute values because a vector cannot have a negative magnitude. It only has a positive length, right? So forget about the negative signs. I think when you square it anyways, it becomes positive, if I'm not mistaken. So 860 square at, we get 739. So 739, comma 600. plus 490 squared. That's 240, 100. Right, let's add these two numbers together. So 240, 100 plus 739, 600. That's 979, 700. 979, 700. And now we would like to get our square root. So square root of that, what the hell do you get square root? I think this is the icon, is it? Yeah, it should be, right? Yeah, it's 989. Nine eight nine point 989.79. Right? So this is the magnitude of my vector. This is how long it is. It is 989 pixels and 79. If I let's take the first three digits. 797 797959 797959. Let's get all these digits to get as accurate of reading as possible. 797959 1815. 1815. That can't be any more accurate than this. This is the magnitude of my vector. This is how long my vector is. Right? Okay, so how do we normalize our vector? Well, that's pretty easy. Luckily, I remember that part. To normalize your vector, you take the x-axis and the y-axis, and you divide both the x and y by the magnitude, which is this. Right? So let's do that, and then you add them together, obviously. Let's do that, right? So in here, kind of this area, let's do this. So we basically say 860 divided by 989.7979591815. Oops, I hit the mic again. Apologize. Let's do that. 860 divided by 989.7979591815. Right, you get 0.8686. Let's do this, equal to 0.8686. 886. Let's take two more digits. So 86886 418. Right, so that's only for the x-axis. What about the y-axis? Well, the y-axis is 490. Right? Divide by 989.7979591815. The value of that is divided by 898. Oh, sorry, 989.7979591815. That gives me 0.45. That can't be right. Something wrong here. I did something wrong in my math, I think. Okay, I think I did something wrong with my math. I'll check in a second. Ooh, yeah, I think I did something wrong. Okay, hold on, we'll see. That's give me 0.495 495050, right? And so the reason I know this is wrong is because if I add this value and add this value, add these two, Oh, no, I didn't do anything wrong. Okay, so this is the y-axis normalized, and this is the x-axis normalized. So now my new values are, here are my new values. My new values are of how long my vector is, right? Before, my vector was 860 and 490. Now my vector is this long, 0.8686418. So that's the x-axis, comma, 0.495050, right? So now this is my vector. Before it was 860, or again, this is all negative value, minus 860, and just add the negative sign here, so that's not a big deal. 490. Those were my, this is the y-axis. That's how long my vector was before. Now it's this long. Now, in order for you to check if this is a unit 1 vector, essentially what you do is you add up those two values, right? You find the magnitude. So this is my vector here, and I need to find its magnitude, right? We found the magnitude of this vector before, right? We did this operation over here. We did that here. We found the magnitude is 98979.7979591815, right? That was the magnitude. Now I need to find the magnitude of this vector, right? The only reason I need to find this for this vector is just to prove it to you that this is a unit 1 vector. So this number, or these two x and y, should give me a number 1 or unit 1, right? So let's try to prove that. So we need to do the same operation here. Essentially square both of these, add them together, and get the square root. So let's square them. So if I say 0.8688, sorry, 88. Is it 88? Yeah, it's 2 8s. Never mind. Sorry, do it again. 0.86886418. Okay, that should be squared root. Not squared root. That should be squared. And square it, you get 0.754924. Okay, that's squared. Plus, let's square the other value. 0.495050. Square that. We get 0.2450245074. Let's add these two numbers together. Sorry about this. All right, let's add these numbers together. 0.754924 plus 0.245074. Right? Get the square root of that. Doesn't matter. It's almost 1. You can see how it's 0.99999. We can round that to 1. So this, you can see here, add this with this, it's a unit 1 vector. Cool. So now I've proved that basically, in order for you to get the magnitude, right, you take those two x and y axes, x and y, square them, add them, get the square root. Once you do that, you get the magnitude, which in my case, this is magnitude. In order for you to normalize this vector, to make it a unit 1, to make it small rather than large, what you need to do is to go ahead and divide both the x and y components by the magnitude, by the length, right? And it makes sense because if your vector is this large and has an x and y, in order for you to make it smaller, you just divide by itself. by the length, by its own length, right? And so now that we've divided its own length, right, by the magnitude, we get those two values. And that's it. We could have stopped here. We could have stopped at here and here. This is the normalized vector. My new normalized vector has an x-axis of minus 0.86886,415 and a y-axis of minus 0.495050. Right? That would be just the end of it. But I wanted to prove to you that this is a unit 1 vector. And a unit 1 vector essentially means is that its magnitude, the magnitude of the vector, equals to 1. So how do we calculate the magnitude? Well, again, you take those two numbers, square them, right? And get the square root. So this is my new vector, right? So now I take this vector, square it. Take this vector, square it. Again, I ignored the minus signs. Take this vector, square it. Take this vector, square it. Add them together and get the square root. And doing that, you saw that this, adding those two, squaring them, gets me very close to 1. Right? It didn't get me to 1, and the reason it didn't get me to 1 because I lost some data. I didn't take the entire number, right? But it's close enough. 0.999998 might as well be 1. So this is a unit 1 vector, which means that this vector, you can see it still retains its direction. So the direction is saying is that I'm looking to the left. You can see the x-axis is negative. I'm looking to the left, and then I'm also looking up, right? And minus y is up. So minus x and then minus y. And so that would be on my vector over here. Cool. So that's all we need to do. We need to do all of this, right? So the first thing I would like to do, right? The first thing is subtract my current position location, or the target, from the current location. Once I do that, I'll get my direction vector. My direction vector has to be normalized. In order for it to be normalized, I need to find the magnitude. Once I find the magnitude, I divide the x and y component by its magnitude. When I do that, I finally get a normalized vector that I can increment my position by. So now this vector, sorry, not this vector, this vector over here, right? I can say plus equal position. This is my bullet, so I do bullet dot position plus equal, right? I add that by minus 0.8688, right? Comma minus 0.4950, right? So now I'm incrementing, I'm moving my bullet in this direction in small increments rather than moving it in larger increments like here. I'm moving it in very large increments, pixels. I'm moving them in subpixels, so very small increments. So that's the entire idea, right? That's the entire thing. Okay, so let's do that. So, ow, I dropped my pen. You know, yesterday was a very painful day for me. I was trying to grab my phone, and so I grabbed it, but at the same time I grabbed the cable of the mic because my phone was next to my mic, and so my mic fell, and I tried to catch my mic. Well, I didn't try to catch my mic, but by pulling the mic, my phone fell from my hand, which I just picked up, and it smacked into the wall. And now my phone is all black, so it has now a silver dent on the top left corner of my phone, which makes me very, very, very sad. I tried coloring it in black just to pretend that it's not there, but I don't have any permanent black thing and black marker, and I think it will show off the difference anyways. And so today I was at a friend's house, and I was just walking by, and my watch hits the table, and now I scratched my black watch too. So it's been horrible 2 days, okay, in terms of technology getting fucked. So yay me. At least I didn't break the screen or anything, and the phone functions normally, which is fantastic. But it has a silver dent, which I do not like. I like to take care of my tech. I don't like them to be smacked. Now, some of you might wonder and ask, why don't you just have a cover like a normal people, you idiot? And my answer to that is because covers make your phone look so ugly. Yes, there's a possibility that you're gonna drop your phone, obviously, and damage it, but like, it looks so much nicer without a cover. So I never put covers on. Anyways, I digress. Who cares? Moving on. Okay, cool. So what I want to do now, I have my vector here, right? So I'm just gonna remove all this code. Okay, for my std vector string that I just did here. And so what I would like to do is, well, the first thing I need to do is create a bullet, right? That's the first thing I want to do. So in the top area, not in load, right? I'm gonna I'll put it down here. It doesn't matter, I'll put it here. So I'm gonna do SF rectangle shape, and I call this a bullet. So just single bullet to train on this for now. Just a single normal bullet. And then my bullet is going to have a constructor, which is gonna have a size of, I don't know, 10 pixels by 5 pixels. That's how my bullet is going to be. Right? And so now I would like to draw my bullet. So window.draw bullet. Okay, so let's see if it draws the bullet correctly. And you can see my bullet is at the very top left corner. I can make it a little bit more obvious by doing one of two things. First, make the fucking bullet a little bit bigger. So let's do 50 pixels by 25 and moving it. So sets this position. SF vector to F. Set it somewhere else. Let's 100 on 100. Right? Or let's do 50 and 50. So I'm moving the pixel, moving the bullet a little bit to the right and a little bit down, which is over here. This is my bullet. You can see it's over here. All right. So now what I would like to do is shoot the bullet, or make the bullet move from one location to the other. Right? So I want to stay here, right? I want my player to be here. And doing some basic math, that basically I would like to, one second. Okay, so I would like to, so I know that this here is 0 on x-axis. So I want to move all the way here. Right? So if this point was 0, then this point and this point is 1920 by 1080. That means this over here is roughly 1,750. 1,750 on x, right? And then if this is 0 on y, right? If this is 0 on y, well, this it's 0 on y, and move all the way down here, then this is roughly 900. Okay, so 1,750 by 900, right? So I'm gonna draw a rectangle around this player, just to compare it, see if I got this right or not. So my player position is gonna be moved. So his position is going to be. Am I ever setting the position? I should be. So I'm not setting the position. It seems so. So let me set the position of my player. So I'm gonna do player.set position. SF vector to F, and the player position 1,750 and 900. And notice what I set the position. I set the position when I'm loading the sprite, right? I could have put it anywhere. Like I could have put it in here, for example, right? But I could have put it in here, it doesn't matter. But the important part that I want you to keep in mind is that you only want to set the position once, because this is my initial position, where my player is initially. I don't want to put it in the while loop, because if I put it in the while loop, that means that I'm always setting the position, my player position, to 1750 by 900, which means if I try move it with my keyboard, it's not going to work. So let me show you an example. So, close. A little bit far, a little bit far. I need to move it a little bit left and a little bit up. So, not 1750, maybe 1650. Instead of 900, it's probably like 800. Close. I was very close. There you go. Look at me, I'm so good. Alright, cool. So, here's the thing. So I've set the initial position of my player here, and I can now move my player, right? I can move him normally like I normally would. However, if I put this, set the position of the player inside the loop, that means every frame I'm setting the position, which means if I try move him using the keyboard, that's not going to happen. You see, I'm pressing my keyboard. I don't know if you can see this, but he moves very slightly to the right and then stops. Because every frame I set the position, if I press the A key, I move him 1 pixel left, and then I set the position back to where it was. So even if I do 100 here, so every frame I set his position, I move 100 pixels left, so I'm going to press A. You can see he moved left. If I let go, he goes back. Because every frame, I'm resetting its position. I'm telling him to put the position here. That's why I only put this. I only set this as initial position, and I only set it once, right? All right, so that means my bullet is also going to be set, will be set around that location. So my bullet position is going to be also over here. Instead of, I'm just going to do 600 pixels rather than 650, which means it'll be a little bit on the left of the player. Yeah, that's my bullet. So now what I would like the bullet to do is move in this direction, right? Move in this direction. I want my bullet to go there. Okay, so how do you do this? Again, target, which is my enemy, minus the current position of my bullet, and that's my direction vector. Okay, so let's do that. So what I'm gonna do is I'm gonna create a function. No need to create a function. I can just do it. So I want to calculate the direction only once, right? I don't want to keep calculating the direction over and over and over. So again, I don't put this in the main loop. I put it outside to initialize it. So I'm gonna create an array here. Calculate direction of the bullet. All right. So put that in here like this. So now I can put some code in here. So how do you calculate direction? Again, the first thing we need to do is get the target position. So the target position is my enemy. So I'm going to create a vector to f, right? Call direction equal to enemy, or skeleton, I think. Skeleton sprite dot get position minus bullet dot get position. Jesus Christ, can you work in here, please? Get position, right? So subtract both of these. Now I have my direction. Target is the skeleton. My current location is the bullet itself, and a bullet is just my rectangle shape, right? So now that's my direction. Now I would like to move the bullet in that direction. And to do that, I have to do it in the while loop, in the update, because I updated every frame. Okay, but notice when I do this, something interesting is gonna happen. Remember, we're moving my bullet by a really large amount, so we're just gonna do it anyways. I'm gonna say sf vector to f bullet position equal to bullet dot get position. So this just makes me store the bullet position in a variable. It's a little bit easier to work with. I don't have to do that. In fact, I'm not going to do that, but I'm just going to do it for now, for a little bit. And then I'm going to say bullet dot set position. I'm going to do bullet position plus my direction. Okay. So this is just an easier, rather than just typing this inside, right? I can just type this inside and I can ignore this line completely. So I just get the previous bullet position and I add the direction to it, and I set that position, so I'm incrementing that. I could do that, right, if I wanted to. It looks a little bit uglier, but it's fine. I can do it, which is here. So now what I'm doing is every frame I get the previous position of my bullet, I add the direction that I would like to move in, and then I set that as the position of my bullet. The problem here, I'm gonna press play and the bullet is gonna disappear. It's gonna move extremely fast. Well, it disappeared. It didn't even move fast. It literally disappeared. The reason for that is that my bullet location is over here, right? It was over here. And what I'm basically saying is that the bullet is going to move. This is the vector of my bullet. This is how long the vector is. And so what I'm saying that every frame number 1, move by this amount. So this is the first frame that's going to be here. The second frame, move by this amount. So now it's outside the screen. That's in only 2 frames. Third frame, move by, again, the same amount, right? Now it's way outside the screen. So rather than doing that, I need to make my bullet, I need to normalize my vector, make it small, so it moves in small increments. I could do that, which I am going to, but as a hacky way, just to make this work, what I'm going to do is multiply the direction by 0.00 or 0.1f. So that does, it takes the direction, right, and multiplies 0.01 by for the x and y coordinates. So the x and y coordinates of my direction is going to be multiplied by 0.01, which is going to make that value much smaller. So if I go to my calculator here, and I take, what was it? 960 when we calculated this? 860. So if I take 860, multiply by 0.01, now you can see it's 8.6 pixels. So now instead of moving by 860 pixels every frame, I am moving by 8.6 pixels, right? That's just, we're reducing the speed. We're not normalizing the vector. We're just reducing the speed, right? Which is a hacky way of doing it, but it's fine. So now you can see the bullet moved, but it moved way too fast. So I have to do 0.001. Now it's going to be even slower, right? You can see that. It's still too fast. I need to reduce that even more. There you go. You can see now my bullet is moving in that direction because that's where my enemy is. Okay? What if I drop down the enemy? What if I put the enemy a little bit down? So if I go to the skeleton and I set his position instead of 100, let's say 700. So now he drops way down. So now look at the bullet, what's going to do. Now the bullet is going to move in his direction. It's no longer moving up here because the enemy is no longer here. The enemy is over here. So now the bullet moves in this direction. Cool. And if I move the enemy to the right, let's say I move my skeleton, the enemy skeleton, to the right, all the way to the right. So let's do this 1200. Right? And I'm gonna put the player at 0, 0. Instead of 1000, maybe 1600, right? I need to set the bullet position. Hold on. The bullet position. You know what? I'm just gonna set the bullet position to the player position, right? It doesn't matter. So now this code, this here, right? I'm gonna move this line of code because I cannot just type here player, where is it? Is it player? Yeah, player sprite. I can't do player sprite dot get position. I can't do that in here, right? Because player sprite, I still haven't initialized it, right? There's no player sprite up here. The player sprite is way down here. You can see the player sprite here. So I need to move this line from the top to kind of the bottom to make this work. So I need to move it here before the direction. So now here what I'm saying, just set the bullet position to the player position, wherever the player is. Alright. So now if I press play, you can see the bullet is gonna move from the player, right, to the enemy, which is this enemy. And this is my player over here. I'm moving the player, right? But the bullet moves towards the enemy. So now I know all this works. Like all of this works, all of this is great. right? We did it in a hacky way where we multiplied by a very small values to normalize it. But let's actually normalize it. As far as I know, SFML doesn't have a normalization. Yeah, they don't have. So SF vector to F dot or X X dot. Yeah, they don't have a normalize function. So we have to make our normalize function. And that can be done really easily. It's not that difficult. So at the very top, I'm going to say void normalize vector. Right? This will take an SF vector to F called vector. Okay, so how do we normalize a vector? Let's look at this formula. Take the xy components, square them, and then get the square root. So vector dot x plus vector dot y. Right? Now to square something, there's a cool trick. Rather than just doing square, it's basically multiplying it by itself. So if I take vector x, multiply it by itself, that's the same thing as square. And so if I take this and multiply it by itself, it's the same thing as square. And look, the multiplication will happen before the addition, because, you know, rules of mathematics, multiplication always happens before addition. So we'll multiply this first, then we'll multiply this first. When these two multiply, they'll be added. When they're added, we need to get the square root. Now to get the square root, we have a library, a standard math library called CMath. Or math? Is it math or CMath? CMath is for C. This is just math. Okay. So now I can do SCD square root, right? And square root will take a double as an input. So what I can do is just take this, put it all in here. Okay? And so that's going to give me the magnitude. So I'm going to do float m equal to this. So that's my magnitude, right? Okay, so square root takes a float. This is the float. It's going to return a float, which is my magnitude. Now all I have to do is do dot x divide by m, right? So vector, or I'm going to make a variable here, sf vector 2, vector 2f, oops, vector 2f, normalized vector. Okay. Normalized vector dot x equal to normalized vector dot y equal to vector x dot y, right? So we get the magnitude, and we get that by multiplying with the x components, multiply the y components by each other or squaring them, adding all of this, getting the square root. That's my magnitude. Now I create a new variable called normalized vector. This is going to be my normalized vector. My normalized vector is going to be equal to vector dot x, which is this one, the one that we just came in, divided by the magnitude, right? Just like here. So we did this part, we added this part, and we got the magnitude. Now this part, where we take 860 and divide it by the magnitude. So this is the vector that I want to normalize. I divide the x component by its magnitude. And the vector that I want to normalize, I divide it by its own magnitude. Once I divide both of these, I store them in a new vector called the normalized x and y vector. Now I would like to return the normalized vector. So it means that this has to be SF vector 2f. So now this function returns a vector 2f, which means that this is now normalized, right? This is a normalized. So if I put a vector in here, whatever vector here, I'm going to do all this math operation on it, right? Normalize it and return the normalized value, which is super cool. So let's normalize my direction. So now in here, I'm just going to do direction equal to normalize vector, and I pass in the direction again. So the direction will be passed into this function. It will go through all this math, and then we're going to return the new vector, the new direction vector, which will be stored back inside direction. So now direction is now normalized, right? I put in the unnormalized direction over here. I put it inside here, and then the output will be the normalized vector for normalized direction. So now I don't have to multiply by this hacky number, right? Because if I press play, it's going to be slow because now this is a normalized vector. You can see it's still a bit fast, but it's nowhere like before. Now it's normalized. My vector is normalized. So now I can control the speed of my bullet by multiplying the direction by speed. I'm going to call this bullet speed, and I'm going to call this bullet direction. So bullet direction, bullet direction, bullet direction, right? Then bullet speed. We need to create this variable, so I'm going to create it at the top over here. So float bullet speed equal to 5. Or I can just do 5.0f. It doesn't matter what you do it, how you do it, but it's fine. But now my bullet speed is faster, right? So now it's going to move much, much faster. So now look what I'm doing. I'm taking the previous bullet position and I'm adding to it the direction multiplied by the bullet speed. So now I can control the bullet speed up and down, faster and slower, depending on what I want. And you can see now the bullet speed is much faster. And if I think that's way too fast, I can reduce that. So now instead of 5, I can do 0.5f. So now it's half the speed. Which half the speed, you can see now the bullet is moving a lot slower. Right? But now this is not hacky way. This is not the hacky way. Because remember, before we had to multiply by 0.000, like 1, like a very small value. Now this is just the normal speed of my bullet. I normalize my vector, and I multiply by the speed of my bullet. Now my bullet is moving in that direction. Which is great. It's fantastic. All right, cool. We've done all of that. Now my bullet is moving in that direction. Now the next thing to do is actually have more than one bullet and let the player fire these bullets. So instead of creating a signal variable, now we need to create a vector or a list of variables or a list of bullets. All right, that can be easily done. So what I'm going to do here, I'm going to say std vector, right? And this is going to be a type rectangle shape called bullets. So notice I've created a vector of type rectangle shapes. So this bullets variable is going to contain multiple bullets of type rectangle shape, right? Okay, so I can comment these two lines. I'm going to keep the bullet speed. I like the bullet speed. But I'm going to comment this line code out because I don't want to create a bullet anymore. Now it's bullets. Okay. Now, the direction. Right, I need to calculate the direction of my bullet. Or we want to set the bullet speed. Right? We want to set the bullet, so we will do that later again. And we'll just comment all this. Literally, any code that's related to the bullets, we'll just comment it all out because we want to start a little bit fresh. Okay, so all I have here, even the rendering part, comment all that out. So all I have here right now is just simply the vector of bullets. Right? That's it. Okay, and the bullet speed, obviously. Okay, so now I need to add bullets to my vector. So what I can do, I can have an if statement. If SF mouse button is button pressed, right? And I do SF mouse button left button. So if I press the left button with my mouse, I would like to fire a bullet. So bullets dot pushback SF rectangle shape, right? And the rectangle shape is going to be, if I remember, this is the size of my bullet. That. Oops. There you go. So let's look at this line of code. Whenever I press the left mouse button, right, I go to my bullets variable. And this is my bullets variable. In my bullets variable, I add a new element to this list, or to this vector. Let's call it a list. This list, I'm adding a new bullet. The type of the bullet is a SF rectangle shape because the vector here we created is an SF rectangle shape, right? So I'm pushing a new SF rectangle shape with the size of this rectangle shape of this size, right? And so there you go. If you want this to look a little bit nicer, maybe this entire line is a little bit too confusing, you can split it down into multiple parts. You can say SF rectangle shape, new bullet, right? And you give the size of the bullet, and you're inserting just a new bullet. So you're saying bullets that push back new bullet, which is this, which has a size of that. Whoops, which has the size of that. So this is my new bullet, a rectangle shape with a specific size, and I just push back a new bullet, right? You could do that, but there's no need for making it two lines. We'll just do it in a single line, like that. All right, now that we've added a bullet, right? We've pushed a bullet here. Now I need to do what I was doing before. So I've pushed a new bullet. I can delete this line of code. What else I was doing? Well, if I scroll down, I was setting the bullet position. You can see here bullet.set position to the player position. So I would like to do that. So when I click, the second I click the mouse, I push a bullet, and now I need to get the last bullet in this list. To get the last bullet, I do bullets, open these brackets. They're called array brackets or square brackets. Bullets.size -1 dot set position. This entire line of code. Okay. Now the question is, why did I do bullets.size -1? Remember last lecture we talked about this? We said if I want to get the last element, right? The last element that I just added in here, I get the size -1, right? So this is my list of my bullet. If I add 3 bullets, 1, 2, 3, right? If I do bullets.size, that'll give me the value 3. So it tells me there are 3 bullets in here, right? And what we want is the index, right? I want the index of my bullet so I can access the last element. And to get the index is n-1, so 3 - 1, right? And I get 2, which is the index of the last element. So same thing here. I push a new bullet over here, right? To get, and now that I pushed a new bullet, I want to get access to that bullet. I want to set its position. I want to manipulate that element that I just added to this list. So I need to access that element. To do that, I go to my bullets list, right? And I find the last bullet. And to find the last bullet, the index of the last bullet, I just say bullets.size, right? Which will become 1. Before, like if I delete those 2 lines, the bullet size is 0 because I haven't added a bullet. But at this line, I did push 1 bullet. So when I say bullets.size, this is going to return a value of 1. So 1 - 1 is 0. So the last element that I just added has an index of 0 because there's only right now 1 bullet. If I added the second bullet, then bullet.size is going to be 2 because now I have 2 bullets. So I want to access the last element, right? 2 - 1 is 1. So the last bullet that I added has an index of 1. Right? And if you want this to look a little bit nicer, maybe a little bit too confusing, you can do int index or last element equal to bullet.size -1, and you can just access the last element right here. So now I'm saying bullet square brackets last element, which will be however it is, 0, 1, 2, 3, whatever the last element is, and I set the position of my bullet in the last element. So the last the thing that I just spawned, essentially, when I click, whatever I just spawned, I need to set its position to the player position. That's my entire goal. And I want to only do it for the last element because that's the bullet that I just spawned. Right? So you can do it this way. I'm going to go back to the way it was because it's a little bit nicer. Actually, I'm going to do this multiple times, so maybe yes. Instead of last element, I'm just going to do I, because I is famous for being kind of the thing you want to access, the element you want to access. Okay, so I set the position, right? What else do we do? Well, we need to calculate the direction. So let's copy these two lines of code and paste them here. So I don't need this line because this is just takes the bullet, set its position to the player position. We've already done that here, so I can remove this line. And so this line basically gets me the bullet direction is the enemy, and I want to get the bullet position. And again, to get the bullet position, the last bullet that I just spawned, I do just bullet I. Bullets I get position. So it's my bullet direction. And now I want to normalize that direction, which I do. So now I have a bullet direction which is normalized. Right? Okay. So what I want to do now. Now I would like to move that bullet in that specific direction. Right? Now, here's what I just realized while writing this code and kind of explaining all this to you. We have multiple bullets, or we're going to spawn multiple bullets by pressing the left mouse button. And the problem here is that we have a single direction variable that holds a single direction for my bullet. Single direction, which means all the bullets will always have the same direction, no matter what. Now, sometimes that's not true. Sometimes I want like the bullets to have different direction. If I want to, that's a possibility. But currently with the code we've written, all the bullets will have the same exact direction, which is not good. Okay, so we can solve that later on, but for now it's fine. It's not the end of the world. Okay, so I would like to move now all my bullets. Well, before I move my bullets, I would like to draw all of them. So let's draw all of them. So drawing happens here. Okay, how do we draw a vector of bullets? This here. Well, I can't just say window.draw bullets, because bullets is a vector, is an std vector, right? I can only draw a single element, which is a rectangle shape. I can draw a rectangle shape. So for example, if I say I would like to draw the first element, I can do that. Or the second element, I can do that. Or the third element, I can do that. But I want to draw all the elements. So how can we do that? Well, a for loop. So for every single bullet inside the bullets list dot size, I would like to draw bullets at I. So now, after I draw the skeleton in the player, I loop through all the bullets and I draw every single bullet individually. So I go here, draw a bullet, and then go here, draw a bullet, draw a bullet. When I'm done with drawing all the bullets, I can display everything on the screen. So we're done with the bullets, drawing them. How about now we move them? Well, I can't move the bullets inside this if statement because this code only executes if I press the mouse button. But I want to keep moving my bullets even if I stop pressing the mouse button. So that means that this code has to be out here. Okay? So again, we need another for loop for all my bullets. And now I would like to, how do we move something? Well, remember we do player sprite.set position. We get its position, we move by a certain direction. We already have the direction calculated here, and we already know the bullet's position, initial position, so we can just move it. So if I copy this line and modify it a little bit, okay, instead of player sprites, this now it's going to be bullets I to access every single individual element, every bullet in the bullets list. When I set their position, right, their position is going to be, well, the bullet position. So dot get position. I want to get the bullet position, plus I need to move it in a specific direction, which is going to be bullet direction multiplied by bullet speed. Now, here is a slight problem. There's an error for bullet direction, and if you read the error, it says identifier bullet direction is undefined, which means that it cannot find this variable. But how come? We created the variable. Let's try over here. Like, this is literally the variable. How can it not find it? Well, remember we talked about scopes? We said that everything has a scope. So this if statement has this scope, and everything lives on this line, or created on this line, and it dies on this line. So that means that I'm creating this variable over here. So it only exists in the scope. It cannot exist outside the scope. Okay, well, how can we make this bullet variable exist outside the if statement? Well, rather than creating the variable in here, we create it somewhere else. So you can see here, I'm creating it, and the way I create it is by just saying sf vector to I bullet direction. So only this part, the part that I highlighted here. So this part is the creation part. I created the bullet here. So rather than creating it in if statement, just create it somewhere else, which is going to be, let's say here, outside the loop. And the reason I picked outside the loop is because if I create it inside the loop, that means that the direction is going to be reset every single frame, which I don't want to. I don't want to reset the direction every frame. I don't want to set it back to 0 every single frame, because if I do that, I basically create the direction on this line. So here's the thing. I created it up here. Now I can just use it. I don't have to create it again here. So I can just delete this and I can just use it, right? And my error is now gone, right? But my point is, if I create the bullet direction inside this while loop, what's happening is this. Every frame I'm gonna create the bullet, and then I'm gonna go down, do all of this code, calculate the direction, move by a certain direction, right? And then we're going to go here, and then I'm going to restart the loop to go to the second frame. The second frame, I reset my direction back to 0, right? At the very end of my loop, this is where my loop ends. When my loop ends, I destroy all variables that I just created inside this loop. So look at this line, this dotted line. Let's follow the dotted line. The dotted line goes all the way over here. So it means I created this variable in this loop, which means at the end of the loop, this variable will be destroyed. However, if I move this variable outside the loop, then this variable will only be destroyed if this scope ends, the main scope ends. So where's the main scope? Here's the main scope. You can see this is the main scope. Let's follow this line. Main scope, main scope, main scope. You can see that the bullet direction is in the main scope. So it will only be destroyed when the main scope is over. And the main scope is only over when we exit the game, because we are forever stuck in the main loop, right? And so there's nothing wrong with putting the variable here, by the way, right? Just the only issue is that I'm creating the variable, I'm setting its value, I'm calculating its value over here, and then I'm destroying it, right? The problem that we're gonna find is that, actually, we are going to have a problem. The problem that we're going to find is that if I stop pressing the left mouse button, my bullet direction is not going to be recalculated. So if I create it over here and I destroy it later on, the direction data will always be gone. This math calculation is always gone because we destroyed the variable at the end of the loop, and we recreated it again without doing the math again, because we only do the math if we press the mouse button. And so now we're moving the bullet in a completely wrong direction. And I can prove that to you. So if I press play, right? And if I click my mouse button, I'm going to click and hold my mouse button. I'm holding. You can see those are all my bullets. If I stop holding, the bullets all stop moving because the direction is reset, right? Direction is just, well, reset. It's destroyed. It's reset to 0. So if I put this variable outside the main loop, and if I press play now, I'm gonna only press a few times. As you can see, the bullets are moving on their own. I'm not pressing the mouse button anymore, right? So it's important that you know where you're putting your variables. In the loop, if you create a variable in the loop, it's gonna be destroyed in the loop every single frame. So first frame, it exists. Second frame is it's not gonna exist. So that's why I create my variables outside the loop. just like how I create these variables outside the loop, because I don't want them to reset. I want them to store that data until the end of the program, which is very important. All right, but essentially, so here's my bullet direction. I'm gonna put the bullet direction next to the speed, bullet speed. So bullet speed, bullet direction, and bullet list is all up here, right? And I can delete this line of code, right? So let's do a quick review. When I click my mouse button, I push a new bullet with a specific size. I get the last bullet that I just added. I set the position of the last bullet to the player position. I calculate the bullet direction, and I normalize the bullet direction. Every frame, I loop through all my bullets, and I move my bullets by taking its previous position and adding to it the direction by speed, which means that the bullet is going to move in a certain direction with a certain speed from its previous position or known position for every single bullet. So that's update. In draw, we go through all the bullets and we draw every single bullet individually. So now if I click my mouse, click, see, I have multiple bullets, which is kind of cool. If I move the player, you can see the bullets spawn where the player is. Right, I'm spawning the bullets where the player is, and all the bullets, notice all the bullets are going towards the enemy. All of them are going towards the enemy. Right? But they're not going in the correct direction, because here's the thing. You can see there are some errors. So if I move here, I go down while this bullet is now still moving straight. It's not moving in this direction. It should be moving in this direction. So what's going on? Well, because the bullet at the top, the direction of the bullet at the top changed according to the last bullet that I added. Because again, that doesn't make quite a lot of sense. The reason it's a little bit messed up is because, again, we only have a bullet direction, one variable for all the bullets. So if this bullet direction changes for some other bullet, that means all of the bullets direction will also change. So how can we solve that? Well, rather than calculating the direction only once, because I only calculate the direction once when I click the mouse button. So rather than doing it once, I do it every single frame. So now every loop, so when I press the mouse button, I add a new bullet, I get the last bullet, and I set its own position to the specific location. Now I loop through every bullet. I calculate the direction of my bullet over here, and I subtract from it. I get the skeleton. This is the target minus the player position, or minus the bullet position. The target minus the current position. That's the direction. I normalize my direction and I move the bullets in that direction. So I do that every frame rather than doing it only once. So now I really don't care if I destroy this bullet variable. So you see, this bullet direction, I don't care now. I can just put it in here. I can just do this. Now I'm creating the bullet direction in the for loop and I'm destroying it at the end of the for loop. And I really don't care because I did the math, I moved the bullet in that direction, and I'm done. Now I can recalculate it again. So I don't want to keep this bullet direction forever. I just want it just to do the calculation and set its position or set its direction over here, right? So now if I press play, and I shoot the bullet, now all the bullets will always, no matter where I am on the screen, they will always move in this direction. You see, now they're merging. All the bullets are merging to go to this point. Right? They all go to this point, which is the top left corner of the enemy, which is where it is right now. Right? Now, I feel like I didn't explain this very well. Right? So let me try to reiterate on this point. What we were doing before when I click my mouse button, I add a new bullet, I get the last bullet, I set its position to the player position. I calculate the bullet direction, and I normalize my bullet. That's only happens once when I click my mouse button. Okay, only once. Now, every frame, whether I clicked my mouse or not, every frame, I update the bullet's position. The bullet position is I get their last position and I move them in a specific direction, which I calculated and I stored here. Why is this a problem? It's because, let's say, and you saw the problem before. Let's say over here, this is my screen. This is my screen. My player shot a bullet over here. So now, and the enemy here. So now I know that the bullet should go in this direction, right? But then I move down, right? Now I shot a bullet. So now both of these bullets share the same direction variable. And before the direction was saying go down here, now the direction of this bullet says no, go down there. So now it's more steep. If I move all the way over here and I spawn a bullet here, right? So now the direction of this bullet goes over there. So now we've changed where this direction variable is pointing to. Before, so all bullets share the same direction variable. So this is the same direction variable. The first bullet says go here. So now it's slowly moving there, slowly, not yet. But the player went down, right? And he spawned the bullet over here. So now both of these guys are using the same variables. But because this is the last bullet that I spawned, it overrid what the bullet, or what the direction of the bullet is. So now the new direction is more something like this, right? So it's less steeper. So now both bullets are gonna move, right? Both bullets are gonna move in that direction. But this is not the correct direction, because now it's a little bit less steep. Rather than it's being like this, it's now less steep. So now it's actually gonna correct course and kind of move in this direction. So it's gonna miss the player altogether, the enemy altogether. So if the player is now over here and I shoot a bullet from here, right? Again, all bullets are sharing the same variable. So now this is the last bullet that I shot, and you can see that this bullet, in order for it to get to the enemy, it can just move in a straight line. So now, let's say these two bullets are now over here. Their position is now over here. And where before they were taking this direction, now they're all taking the latest direction, which is straight. So now these bullets now move in this direction. That's why all bullets, it's bad to have all bullets share the same direction. Each bullet should have its own unique direction. And that was the problem. All these bullets are sharing this single variable, which is created at the very top of my class, or at the very top of my program, right? So how did I fix that? How did I change that? Well, before I only calculated the direction with my mouse click. So rather than doing that, now what I can do is calculate the direction every single frame when I update the bullet position. So before I update the bullet position, what I do is create the bullet direction, figure out the direction, normalize direction, move the bullet in that direction, and then move to the second bullet. The second bullet will have a completely different direction because it has a completely different position. The bullet spawns somewhere else, right? So now, because rather than each single bullet sharing the same direction, right? If I spawn a bullet, right, the bullet's over here, and now I know it needs to move over there, right? And maybe it moved a little bit. Let's say it moved over here, right? There was a time period, right? Like 5-10 frames went by, and the bullet now moved over here. And then I spawn a bullet over here. Now this bullet knows it should go over there. And then I go maybe over here and I spawn a bullet, and maybe it knows to go over there. So now all of these bullets, they have different direction variables. I recalculate the direction. I basically go here, check. What's your position? This is your position. I do the math, T minus C. All right, okay, I get the direction, normalize it. Now I calculate direction for this. And then I recalculate direction for this. And then I recalculate direction this. Where before, I only calculate direction once, and only once when I click the mouse button. Which means that now all of them share the same direction. So now if this all of a sudden now the direction goes right, then all of them will go right. Where now, rather than all of them having the same direction, or the same variable, I recalculate, I redo this math every single time before I move the bullet, I calculate its direction, which is not the most ideal thing in the world, right? But it makes sense because later on, if the enemy moves somewhere, I want the bullet to follow the enemy. I could, like, that's something maybe I want to do that. If not, then that means I need to calculate the direction for every single bullet once, and I need to store it in a variable so it's only calculated once. I don't need to do it over and over and over again. I hope this made sense. I don't know if it did. I feel like I talked too fast. I glossed over some things. I didn't gloss over anything, but maybe I didn't explain it too well. The entire point that I want to get to is now, for every bullet in this specific frame, for every bullet, I calculate its direction. Where before I only calculate the direction for all, where before I calculate the direction for just the last bullet that I shoot. And all the bullets used that direction, that same direction. So all of them used the same direction, where now I calculate the direction for every single bullet individually. That means the bullet will follow the enemy if the enemy moves somewhere. Which we can fix that if we don't want that behavior, right? But there you go. The point is now I can shoot, and all my bullets will always go to the enemy, no matter where I am. No matter where I am, all my bullets are going to the enemy, which is cool. All right. All right. So that's for bullets. Okay. Hope that made sense. Now, here's the thing, though. Here's the problem that I have. You see how disgusting this code? Right now, we're at 132 lines of code. And this is really bad. We've written literally all this code in one source file. This is really not great, especially if this is going to be like a big RPG game. Like, we barely have anything. What do we have? We have a player and an enemy, and we're shooting bullets, and this code looks so messy already. You can't imagine creating a whole game on one single source file. That's really bad. So what I want to do next lecture is rewrite this code and split it into multiple classes, right? Or multiple files, and it'll be much, much nicer and much, much cleaner. That's the entire idea. All right. I'm gonna end off here for now. That's gonna be it. Bullets. What I would like to do now. You can just turn off, like, you can turn off the stream right now and be like, okay, thank you, done, if you understood this. If you didn't understand it, I want to go over this one more time because I feel like I can explain this a little bit better. Okay, so if you're good to go, thank you for watching. I will see you next lecture. If not, I'm just going to explain this a little bit more. The whole bullet direction thing, because I feel like it's not quite there yet. Okay, so I'm going to control a little bit of code. I'm going to show you again the old way of doing things. Okay, let's look at this code. What am I doing here? At the very top, I'm taking a bullet. I'm creating a bullet direction of type vector2f. This is a variable that I create. I create it in the main function. So that means this variable will only be destroyed at the end of the program, because the scope of this variable is in the main function, and the main function the main function scope is done when I return 0 over here, right? So any variables you create in the main function will only be destroyed when the program exited. So same thing with skeleton texture, skeleton sprite, bullet direction. All these guys, all these variables will only be destroyed when the program is destroyed. All right, so I have a single variable over here called bullet direction. What am I doing here? Every time I press my mouse button, I push a new bullet. I get the last bullet. I set its position to the player position. Okay, so let's say I add bullet number 0. Let's put this line code, put the side by side, like this, right? So this is So this over here, I create a bullet over here. Right? I set its position here. When I click my mouse button, okay, click my mouse button, added the bullet, got the last bullet that I added, and I set the position to the player, where the player is. In this case, the player is over here. Okay, create a bullet over here. Next, I need to calculate the direction between this bullet and the target, which is the skeleton. So, target minus my bullet position, that's my bullet direction. So this bullet direction, this variable, which existed at the very start of my program, has now the value of the direction of this bullet, which this direction is now this big. I then normalize this bullet direction to make it this big. So now it's much smaller. It's a much smaller vector. So now it moves in intervals, right? But that's not really that important. Anyways. So now this bullet has this direction. Okay, and then I only pressed it once. I didn't press again. I didn't press to add another bullet. So now I loop through all the bullets, which are just currently one bullet. I move the bullet, right? I move all the bullets. I move the first bullet. I get its position, this position, right? And I add to it the direction I want it to move in. And the direction is a small direction because it's a normalized vector. And I multiply it by a certain speed. So now the bullet moved over here, right? So if I do this, so this is over here in small increments because it's a normalized vector, right? A unit 1 vector moved in small increments. So now the first frame was here. The second frame, now my bullet is over here. Okay, great. And then the loop goes over, and then now my bullet moves another frame, or we go to the next frame. Now my bullet's over here. So my bullet has moved 2 locations. My bullet's over here. Okay. What if the player goes here? By the time of those 2 frames, my player goes here, and he spawns a bullet over here. Okay. Notice what happens now. When I click my mouse button, I push a new bullet, which is this bullet. I push a new bullet, and I get the last bullet in this list, which is size -1, which is, I have 2 bullets, so the size is 2. 2 minus 1 is 1, so index 1 is the last bullet in this bullet list. Index 1. So we have index 0, index 1. This is index 0, and this is index 1. All right. So I take this bullet, I set its position to the player position, which is over here. Great. And then, remember this bullet direction? This bullet direction, which was pointing, right? This bullet direction, which was pointing this direction now, right? I override it. I recalculate it. How do I recalculate it? Well, I recalculate the value between the skeleton and my last bullet. This is I. So now the direction is now pointing this way. This is the direction now. Right? And so because this bullet over here and this bullet over here, they both use the bullet direction, because look here. Every frame I loop through all my bullets and I move all my bullets with the bullet direction, which I calculate is essentially here. So when I created this bullet and I calculated its new path with the last bullet and I normalized it, now the direction looks like this, which means this bullet will no longer start moving in this direction, or will no longer continue moving in this direction. It will now, the direction has been updated to say go in this direction. So now the bullet will just go straight, right? Because all the bullets are sharing the same bullet direction variable. And so basically I loop through all the bullets and I say move in this specific direction, one direction, right? Which is bad, right? Because that means that all the bullets are sharing the same variable, and they share, and this direction will be changed depending on which is the last bullet that I spawn. So all these bullets will follow where the last bullet. So if the last bullet is here, and now this bullet will move down, right? If I spawn the bullet over here, which means that this bullet now will start moving down, and this bullet will start moving down. So they all change direction because this is the last bullet that I spawned, and it's moving down. because they all share the same variable. Okay, so how did I fix that? How did I change that? Well, rather than calculating the direction only once when I click my mouse button, I am going to calculate the direction every single time I update the bullet itself. So now I loop through all my bullets, and I can create the variable over here. I don't need to have the variable over there. I can still have the variable over there, by the way. It doesn't matter. Right? I can have the variable at the top, because every loop I'm changing the variable value. It doesn't matter. But I'm creating it over here, right? So now what am I doing? When I press the mouse button, I add a bullet. I get my last bullet, I set its position. That's it. I just set its position to where the player is. Every single frame, I loop through all my bullets. Every single bullet. This bullet, this bullet, this bullet. I loop through all my bullets. Right? And now, what I'm doing, what I'm doing now, right? What I'm doing now is I'm calculating the bullet direction for every bullet. So look, I'm saying skeleton, this is the target, minus bullet I. And bullet I, this is the loop, which means if I have 10 bullets, I'm going to get the first element because I is 0, and then I will increment by 1. So I'm going to get the second element, and then I'm going to get the third element, and I'm going to get the fourth element. So I loop, I calculate the direction, I normalize direction, I move that bullet in that direction. And then I loop again. I calculate a new direction for the second bullet, and I normalize, and then I move that second bullet. And then I go again. I loop, and I calculate the direction for the third bullet. Normalize the third bullet, I move the third bullet. Then I go again. I calculate the direction for the fourth bullet. I normalize the fourth bullet, and then I move the first bullet, right? So now I'm doing this recalculation. I'm doing the direction calculation for every single bullet in a single frame. So this is all one single frame. How is it single frame? Because I only went through this loop once, the main game loop. I only went through this loop once, and in this main loop, I went through all the bullets. So they could be 10 bullets. So every frame I go through 10 bullets. I calculate their directions, normalize all their directions, and I move them in that direction. And then the next frame, I do the same thing. If I didn't click my mouse button, if I haven't added any new bullets, I go through this loop, calculate their directions, and then normalize those directions, and then set their positions, and so on and so forth. Right? So I do that over and over and over, right? So that means now, if this bullet is moving down here, it's still gonna move down here because now I'm calculating its position, its direction. I'm calculating its direction, not just the last bullet over here. They don't all share the same variable. They all have their own directions now. Okay, I hope this made a little bit more sense. Right? I feel I explained it a little bit better, and I think I'm a little bit satisfied with my explanation. So now what I can do is end the stream, and I am going to talk to you guys hopefully tomorrow. And tomorrow we're gonna clean up this mess. There's a lot of code, a lot of disgusting code, and then I'm gonna clean it up. All right. All right. Thank you guys for showing up. I'll see you guys tomorrow.